All right, guys, our next section here in section 9.3, sorry, in chapter 9, deals with angle of elevation and angle of depression. Okay, and we give you a little diagram at the top in terms of what that terminology means. And then the rest of this is really understanding the way a problem is written, a word problem, a scenario that you're given. Creating a diagram is going to be important here so that you know what information is given to you. And since we're in chapter 9, you're going to see that each one of these word problems is going to create some sort of right triangle for us to then solve for something that's missing, something that it asks for you, like maybe the height of a mountain. Okay. So first things first, let's define what angle of elevation and angle of depression mean. First of all, angle of depression and angle of elevation are always measured from a horizontal line. Okay. Now, a lot of times that horizontal line is going to be the same every time. Like a lot of times, and usually the angle of elevation is measured from the ground. Okay. A lot of times that will be the horizontal line. Not always. Okay. But basically, the angle of elevation refers to an angle looking up diagonally from some horizontal line, many times the ground. Okay, so angle of elevation looking up diagonally from a horizontal line. Okay, many times that's the ground. Angle of depression would be basically the opposite of that. It's looking down diagonally from a horizontal line. Now, there aren't a whole lot of horizontal lines in the air that are actually tangible, okay? So many times this is kind of an imaginary line. Okay, we're looking down from the top of a building. Well, we kind of think of that top of the building as like an imaginary horizontal line, and then the angle of depression would be looking down from something that's in the air, something above the ground. Okay. And that's basically what angle of elevation are. The reason we talk about that is because within these word problems, you will be given an angle of elevation or an angle of depression, or asked to find for an angle of elevation or angle of depression. And this is actually where trigonometry comes into the play many times in the real world. As you can see in our first example, we talk about a surveyor. That is an occupation. A surveyor are the people that you guys see on the side of the road that are setting up on these tripods, these cameras that have kind of like a big lens, one big lens on them, and then they set up these cameras in different parts of land, and they are looking for various different things, distances, angles, things like that. So that's what a surveyor does, and this is something he might actually do. So let's read example 1. A surveyor is 1,000 feet from a mountain. The angle of elevation to the top is 32 degrees. Find the height of the mountain. Okay. Well, regardless if the mountain is completely vertical, okay, he's 1,000 feet from the mountain. Okay, so we're going to draw that horizontally. Okay, we've got 1,000 feet from the mountain. The top of the mountain, okay, is right there. We don't know the height of the mountain. It's something that we're going to look for. We'll call that H. Okay, and the angle of elevation to the top is 32 degrees. Here's my surveyor. He's standing right there along the ground. The angle of elevation, that would be an angle from a horizontal line, lots of times the ground, looking up. So I'll put a diagonal line here, and then the angle of elevation is 32 degrees. That kind of matches up with what we wrote that angle of elevation to be. That almost looks like a 52. That is a 32 degrees. Okay, and we're asked to find the height of the mountain. This now turns into our SOHCAHTOA. Okay, this is no longer part of 9.3. We drew our diagram, we took our information, let's solve. So here's my angle that I'm given. This is the opposite side. This is the adjacent side. Using SOHCAHTOA, we should choose tangent of 32 degrees. That's going to equal opposite over adjacent, h over 1,000. Very simply, one step of algebra, multiplying both sides by 1,000, will get us how high, or the height of this mountain. So we've got 1,000, and I'll do this in my calculator. You guys can't see my calculator, but you guys have done this a bunch of times from section 9.1 and 9.2. 1,000 times tangent of 32. We hit Control Enter, and we get 624 point. Round your answer to the nearest tenth, looks like 0.9, and we're in feet here. And that is the height of the mountain. All right, let's move along. An airline pilot sights a life raft at a 26-degree angle of depression. So we've got some sort of airplane here. All right, this is going to be my attempt at an airplane. Not too bad. I don't know what's happening here. It should probably look a little bit more like this. There's my airplane. He sights a life raft at a 26-degree angle of depression. So what we need to do is we need to kind of create this horizontal line. And he sights a life raft at an angle, a downward angle of 26 degrees. This is our angle of depression. Okay. Now you're going to notice that when we're giving you angles of depression, many times this angle is going to end up being outside of the triangle that we draw. Okay, so you're going to have to take note of that. It says the airplane's altitude is 3 kilometers. Well, altitude is measured vertically from the ground. What is the airplane's surface distance d from the raft? Here is our little raft. All right, and we're looking for the distance it is along the ground or along the surface. All right. Now, we have a triangle, we have a right triangle, but we don't have any of the degree measures actually inside of that triangle, okay? So there's one of two things that we can do. The first thing is knowing that if this is a horizontal line and this is a vertical line, that these two angles here would have to add up to 90 degrees. And 90 minus 26 degrees is 64 degrees. So we could do that. Let's actually solve using that. We now have enough information. I'm going to use my 64-degree angle. The side with D, that's the opposite side. The 3 side is the adjacent side. We're going to use tangent again. We're going to multiply both sides by 3, and we're going to put that into our calculator. 3 times tangent of 64 degrees. Control Enter. It is 6.2 kilometers from the plane. All right. Now, we could also find this angle by subtracting these two from 180, right? 3 angles of a triangle add up to 180 degrees. So 90 and 64, subtract that from 180, I get 26 degrees here. Interestingly enough, this angle and this angle are the same. This would be representative of an angle of depression. An angle of depression, the one we were given. This also technically would represent an angle of elevation from a horizontal line looking up, and they actually are the same. They're congruent. And that leads us to our connection question. I want you guys pause here, read your question, read this question, and then try to think about the answer to it. So give it a quick pause. And then once you've thought about it a little bit, maybe you have an idea, you can hit play again and you'll see what the deal is. So it says, as you've noticed, they will be the same degree measure. What concept from first semester could we think about to prove that? Well, if we have 2 horizontal lines, I think we all know that horizontal lines would be parallel. A diagonal line connecting these horizontal lines, we could call a transversal. And then these 2 angles here, the angle of depression and the angle of elevation, those, so angle of depression and angle of elevation, are alternate interior angles. Straight out of chapter 3. Because horizontal lines are parallel, the angle of depression would always be congruent to the angle of elevation. Maybe some of you guys were thinking that. If you did, great job. It should make a lot of sense connecting back to what we did first semester. All right, let's turn the page, get on to a couple more examples. Okay. A person is standing 30 feet from a flagpole. can see to the top of a pole at a 35-degree angle of elevation. The person's eye level is 5 feet from the ground. So that's going to be something that we need to take into consideration. So I'm going to draw my guy here. There's his eye level. His eye level is 5 feet from the ground. We'll have to take that into consideration. From his eyes, he can see up to the top of a pole at a 35-degree angle of elevation. Now that's from his eyes. Okay, so the horizontal line is actually 5 feet above the ground. He's 30 feet from the pole. So what we can find, let's find the height of the pole, but then we're also going to have to add, the height from his eye level upwards, but we're also going to have to add in the 5 feet we don't have of the pole, because we're starting our kind of triangle 5 feet off the ground. So tangent of 35 equals h over 30. We multiply both sides by 30, and then we're going to have to make that adjustment of adding 5 at the end. 30 tangent of 35, control enter. We've got 21 feet equals h, and then 21 plus 5, that flagpole has a height of 26 feet. All right, let's move on to the next one. Example 5. A skate builder builds a ramp of a slope, word from a blast from the past here, of 5 over 6. Now slope is rise over run. Rise is vertical, run is horizontal. That should make a lot of sense. Find the angle of elevation. Okay. Well, our skateboarder here, we've got our little skateboard here. He's got a ramp of, the rise was 5, the run was 16. We're looking for the angle of elevation. Let's use theta. There's our angle of elevation. Again, we have opposite, we have adjacent. Tangent of theta equals 5 over 16. Then theta will be inverse tangent of 5 over 16 in your calculator, and that will allow us to find our degree measure. .4 degrees. Makes sense. Probably can't be like a 70-degree angle. That would be a little too tall to ride a skateboard on. Example 6, I'd like you guys to do on your own. A woman is standing 2 city blocks from the Empire State Building in New York. I give you a specific building that actually exists in a specific city that also actually exists. Find the angle of elevation from the ground where the woman is standing to the top of the Empire State Building. And I think obviously you'll need a little bit of extra information that I'm sure if you really want to, you could find. Okay, so why don't you guys try example 6, maybe utilizing one extra resource that you might need for one extra piece of information in this problem you might need. And then if you have a question about it, you can check it out. You can check out the hard copy key to these notes after you're done, which will be posted, or you can also bring any questions you have about example 6 or any of these other examples to our office hours. Okay, section 9.3, that's all wrapped up. You know, the most important part is being able to take information given and create a diagram. For the purpose of 9.1, 9.2, and 9.3, your diagram should include a right triangle, and we would solve for whatever we need to using SOHCAHTOA.